All right, class, in this video I'll be doing the first three examples from section 8.1, inverse trigonometric functions, and we're going to focus solely on sine. The first statement reads, if sine of theta is equal to y, then inverse sine of y is equal to theta. And there's actually another way we can write inverse sine. It can be written as arc sine. So if you see arc sine of y or inverse sine of y, they mean exactly the same thing. The converse of the statement says, if the inverse sine of y is equal to theta, then sine of theta is equal to y. And that is the statement we're going to focus on for these three problems. Now there are two restrictions. The two restrictions are y needs to be between -1 and 1 inclusive, and if it's not, then the inverse sine does not have a real solution. Also, the theta values need to be between -pi halves and pi halves inclusive, because sine is not technically a one-to-one function. So if the domain is restricted to that interval, sine becomes a one-to-one function and will then have an inverse. So all of the solutions to the problems need to be between -pi halves and pi halves inclusive. So let's look at the first problem. It says determine the exact value of the inverse sine of 1/2. And I'm going to write out a sentence. If the inverse sine of 1/2 is equal to theta, then sine of theta has to equal 1/2. And if you look at the unit circle gives you two options. Theta is equal to pi sixths, or theta is equal to 5 pi sixths. And what I mentioned earlier is that the thetas, your angles have to be in the interval -pi halves to pi halves inclusive. And only one of these angles is in that interval, and that is pi sixths. So 5 pi sixths is not in the interval. So we're going to ignore that angle, and the solution is the following. The inverse sine of 1/2 is equal to pi sixths. Example 2. Determine the exact value of the inverse sine of -square root of 3 divided by 2. I'm going to start this problem exactly the same way I started example 1, and that was by writing out the sentence. And on your unit circle, you'll find two solutions to this. So theta is equal to 4 pi thirds, or theta is equal to 5 pi thirds. And you'll look and you go, wait, none of those angles, neither of those angles are in the interval -pi halves inclusive. So what we're going to do is we're going to find the negative coterminal angles for each. So the negative coterminal angle for 4 pi thirds is -2 pi thirds. -2 pi thirds is not in the interval. All right, now we're going to find the negative coterminal angle for 5 pi thirds. And that is negative pi thirds. This angle is in the interval. So what we're going to do is we can conclude that the inverse sine of negative square root of 3 divided by 2 is equal to negative pi thirds. And for the third problem, determine the exact value of inverse sine of negative 2.1. And again, we're going to write out the same exact sentence we wrote out for the previous two examples. And you can search and search and search and search, and you'll never find an angle whose sine value is negative 2.1. And that's because negative 2.1 is less than negative 1. So in this case, the inverse sine of negative 2.1 is not real.